The way we deliver drugs today uses essentially 100-year-old technology. And of course, back then, it was very veritable and was the only way that we could probably imagine these things. However, we have a new opportunity. Today, we still use the 100-year-old technology. We're still using glass vials, which are made by extruding sand into long tubes, cutting them, shaping them, and essentially heating this vial up a number of times, 10, 15 times, over 1500 degrees to shape it and make it into this useful container. But it doesn't end there. Then they have to be washed, they have to be cleaned, they have to be filled, labeled, sealed, capped, and then put in boxes and shipped. Of course, it's delicate because it's glass. They actually fragment a little bit. There's always the risk of particles, which is a major reason for drug recall, which is a problem. Then we have to make a syringe, and we have to make a syringe in a specialized unit, a syringe factory, using high-speed, high-tech equipment. And then we have to make sure that these two elements meet. The drug and the delivery device have to meet on site somewhere in the world to deliver this injection to the patient to help them. There's a lot of errors that can occur in that process, and they actually compound each other. You've got the production of glass is multiplied by the problems that you get in manufacturing syringes, and multiplied by the problems of having enough healthcare workers on site to deliver those drugs. So you've got a compounding of all those challenges, which of course we've met up to now fairly well. However, today there are some 50 to 70 million children who are unimmunized, partly because of the COVID lockdown and not being able to reach people for vaccinations. But also there are every year 20 million children who are unvaccinated for various reasons, some of which are connected to glass vials and syringes. So what we imagine in the future is using a new technology, or using a new use for an existing technology. That technology is blow fill seal. So here we have a row of plastic vials pre-filled with a set amount, onto which we assemble needles. And this allows us to transform this humble plastic vial, which we commonly use on eye drops, for example, into an injection device. This is a pre-filled injection device. So we can break one off, we activate, we remove the cap, and we deliver the injection simply by squeezing one of these blisters. And what we've done is we've actually taken away all of those multiple indices which make the delivery of these products in the current format very difficult, and we've simplified it. So this now can be used by an individual, self-administration. It can be used by unregistered healthcare workers called community healthcare workers. They're legally allowed to use these. But also production is faster. They're made and assembled all in one place with commonly available raw materials, all medical grade, and a computer is measuring this each time so we know the dose is accurate. This is the sort of transformative step which is going to make all injections safer in the future and much more available to everyone in the world.